Students, talk on civil engineering. Let us see how we can derive an expression for super elevation. So, what is super elevation? Super elevation is the raise of outer surface or outer edge of the road with respect to inner edge at horizontal curve. Usually, the super curve is provided for horizontal curves or horizontal alignment of your road. Okay, so this super elevation is denoted with small e. So this small e represents the rate of elevation. Okay, the rate of elevation with respect to the width of road. Suppose here let this be A, B, C, D. So here this road in the picture, this road is provided elevation with respect to inner edge. So the outer edge is elevated, or raised with respect to inner edge, right? So usually we'll provide this elevation to counteract the centrifugal force. So at horizontal curve, when the vehicle is moving with its weight, so there will be a centrifugal force acting over it. So if the body is moving in a circular motion, so a centrifugal force will be trying to pull the body outside the circle, right? So that is called the centrifugal force. Okay, so same principle will work even when the vehicle is moving in a circular motion at a horizontal curve. Okay, so in order to take care of that centrifugal force, we are raising the outer edge with respect to the inner edge. Okay, so let us consider this AB has the width of road W, and BC is a rise that we have provided. Okay, let us take E, right? Now, and this, let us consider this is a theta. So what is tan theta here? So tan theta is opposite by adjacent, right? So opposite is CB and adjacent is AB, right? So this is the tan theta, and you know what is AB is W, so you can provide AB has W, right? Or else, you know, with respect the rise with respect to the width that is provided is simply a rate of elevation E. Okay, so that means tan theta is equal to E. Understood? So rate of elevation with horizontal ki vertical enta provide chesam. So this AB is horizontal and this CB is vertical. Okay, so the ratio between the vertical to the horizontal is nothing but E, super elevation, right? Right? So remember this. Now coming to the resolve of how the forces that are acting on the body are resolved. Okay, so let us consider this as a CG, right? So the dead weight of the body is acting vertically downwards, W, and the centrifugal force is perpendicular to this P. Okay, now this W and P, so the here P represents the centrifugal force. This W and P will resolve into sine and cos component, because this body is tilted in with an angle theta. So because of that, this forces is also resolved into sine component and cos component. Okay, so something like this. So this is P, this is a theta, so it will be P cos theta, and perpendicular to this this will be P sin theta. Okay, so similarly for W, So this will be here, this theta is making here, so this will be W cos theta. So W cos theta, and you know the weight will be acting towards the inner edge, right? Wherever the slope is there, towards the inner edge, your weight is pulling, so it will be W sin theta. Okay, so we have resolved all the forces. Now if you see here, so at the both the tires, let this tire be considered as A tire and this is B tire. So at A tire you will be having reaction Ra applying upwards, and at tire B you will be having Rb reaction, as well as at the tires itself you will be having the frictional work also. Friction work also will be you will be having a frictional work, that is Fb here. The frictional force is acting over the tire A, and the frictional force acting over tire A is Fa. Okay, so here F means the frictional work done at the tire contact, right? So these are these are the forces that are acting on the body. Now let us try to calculate or try to find out the equation for the super elevation by resolving the forces, okay, or summation of forces, right? So from the figure, so drawing that figure is very important for derivations. So let us take the summation along x direction, the summation of all the forces in x direction as 0, and the summation of all the forces in y direction as 0. Okay, so coming to the summation of all the forces in y direction, so what are the forces you are having in y direction? So y direction in the sense vertical forces, right? So you're having P sin theta and W sin theta, right? And Ra and Rb, right? So Ra plus Rb. So these two forces are upwards and all other forces are downwards. So I'm taking those as negative. So equating with P sin theta plus W cos theta. Okay. So simply I have written negative on other left hand side and positive on other right hand side. That's it, right? And coming to the some forces in y direction, sorry, x direction. So in x direction you are having W sin theta, P cos theta, and the frictional forces, right? Now frictional forces are acting towards the inner edge. Only P cos theta is acting towards the outer edge. Okay. So Fa plus Fb plus W sin theta. So these are acting towards inner edge, and P cos theta is acting towards other edge. So I have written like this, right? Okay. So here let us send W sin theta to that side, or yeah. So it will be Fa plus Fb is equal to P cos theta minus W sin theta. Okay, and what is the work F here? So F is the frictional work done by the friction, right? So work done by the friction can be written as friction coefficient with respect to reaction. Okay, so frictional coefficient with into reaction is the work done by the friction. Okay, F is equal to friction coefficient into R. So I can write Fa in terms of F Ra plus F Rb is equal to P cos theta minus P minus W sin theta. Okay, and so if I take F as common here, so it will be Ra plus Rb is equal to P cos theta minus W sin theta. So what is Ra and Rb? So here RA plus RB is equal to P sin theta plus W cos theta, right? So it will be P sin theta plus W cos theta. So is equal to P cos theta minus W sin theta. So let us multiply F. So it will be Fp sin theta plus Fw cos theta is equal to P cos theta minus W sin theta. Okay, now let us take the P values to one side and W values to other side. So I'm rewriting this expression. So P cos theta minus Fp sin theta is equal to Fw cos theta plus W sin theta. Okay, so I have just rewritten this expression in terms of P values to one side and W values to other side. Okay, so that means just I have sent this value to this side and this minus W sin theta to that side, right? So now what we'll do, just we'll divide on both sides with W cos theta. Divide both sides with W cos theta. Okay, so if you divide both sides with W cos theta, it will be P cos theta divided by W cos theta minus Fp sin theta divided by W cos theta is equal to Fw cos theta divided by W cos theta plus W sin theta divided by W cos theta. Okay, so here cos theta get cancelled, and here W cos theta get cancelled, W get cancelled. Okay, so what is left? So here P by W is left minus here sin theta by cos theta is tan theta, right? Sin theta by cos theta is tan theta. So I can write it. I can write this in terms of Fpw tan theta is equal to F plus, and here also tan theta. Okay, so here I can take P by W as common. So P by W, it will be 1 minus F tan theta is equal to F plus tan theta. Okay, so what is tan theta? The starting itself we have discussed. Tan theta is nothing but the rate of elevation E, right? So tan theta is equal to opposite by adjacent or vertical by horizontal. This vertical by horizontal is nothing but rate of elevation. Okay, so tan theta is equal to E. So I'm substituting tan theta is equal to E. So P by W 1 minus Fe is equal to F plus E. Okay, and we can write this in terms of P by W is equal to F plus E divided by 1 minus Fe. Okay, so here P by W can be written as V square by GR. Okay, so P by W can be written as V square by GR. So let us write that. So F plus E divided by 1 plus Fe is equal to V square by GR. So this is a formula to find out the super elevation. Okay, so usually we'll use this formula for high speeds, for high speed roads, In case of for a normal speed roads, this value, the denominator 1 plus Fe is neglected. Okay, so if theta is here the theta value will be usually this theta value will be very small. So here F is a lateral friction coefficient. So as per IRC, it is taken as the maximum value is 0.15. Okay, and E, the rate of super elevation, usually it is taken as 7%. Okay, so usually it is taken as 7%, and sorry, this is minus, right? Minus. Okay, so if you substitute these values in denominator, so 1 minus Fe will be more or less equal to 1, will be more or less will comes to 1. Okay, therefore for a normal speeds, for a normal speed roads, for a normal speed, you can neglect the denominator and you can write the expression as F plus E is equal to V square by GR. Okay, so you can remember this equation. Remember this equation to find out the super elevation. Okay, so this is a very important equation that we have to remember, right? I hope you got some clarity. Thank you all.